Hi, welcome back. So we're going to continue our discussion with Trigs. Trigs are kind of fun. I guess you could say they're kind of triggy as well. All right, so for number 5 here. Now for number 5, it looks like we're going to do some really crazy stuff here. But remember, do we know the antiderivative of secant squared? We do. It is on our list. And even the cosecant squared and the sine of x is also there as well. So for this one, we're just going to do this one 3 separate times. So for the first one, what function's derivative is secant squared? So what function's derivative secant squared? And if we go up here, we know that that's going to be tangent of x. So here we're going to get tangent of x plus what function's derivative is sine of x? Well, we've seen that on a number of occasions. That's just negative cosine. So this becomes minus cosine of x. And what function's derivative is cosecant squared? That is going to be our negative cotangent of x plus c1. I'm going to clean this up because I don't like all those negatives like that. So we get tangent of x minus cosine of x plus cotangent of x plus your constant of integration. Now there are other ways we can do this one as well, but that's just one of our answers for it. The problem with Trigs, there are many ways we can get different answers, and we'll talk about those in just a few over the next rest of the year. All right, for number 6, try this one. Well, this is my secant squared and my cosine. I know both of those. Those are on our list. So the first one has a constant of 3, so we're just going to leave it 3. Secant squared, its antiderivative, or the derivative that gives us secant squared, is tangent of x plus 2. And cosine, well, what function is derivative of cosine? Is cosine. And that is just, well, we go up here, we kind of already got that, is just sine of x. The derivative of, we can think the derivative of sine of x is cosine of x. So this is just, whoops, sorry. This is just sine of x, and don't forget the constant of integration. So I'm going to rewrite it just to get rid of the parentheses, make it look nicer, that's all. Plus your constant of integration, and there's our answer. Very easy to do. So for a lot of times with Trigs, though, we do have to get very creative. And that's what happens here. For example, we want to find the antiderivative of cotangent times sine. Now remember, there is no product or quotient rule. So we just can't do cotangent and then do sine independently and multiply them together. That would be a big, big fat no-no. But, and if you notice, cotangent sine is not one on my list. There's nothing that says cotangent sine, cotangent sine, cotangent sine. It's not on our list, so how do we do it? Well, to do that one, we're just going to get creative and have some fun. Use a little bit of what we did last year in pre-calc. Cotangent, I can write cotangent as cosine over sine. So I could rewrite this. Cosine of x over sine of x times the sine of x dx. Don't forget your differential every time. That dx is very important. Don't forget. You need to have this until we're done taking the antiderivative, and we'll see what happens to it later on. Okay, we'll talk more about that later. All right. Notice, though, here, the sine of x is canceled, and what we're left with is the cosine of x dx. Now, we haven't taken the antiderivative yet, which is why I still have my integrand and my dx. But now I'm ready to solve it. What function's derivative is cosine? I know that this is just going to be the sine of x plus my constant of integration. That looks awful, so I am going to rewrite that, make it look a little bit nicer here. The sine of x plus our constant of integration. And there's our answer. So I used my trig rules until I got one that I do know. I know this one. It is on my list. All right. Number 8, we want 1 plus cotangent squared. Now I can take the antiderivative of 1. That's just going to become x. But cotangent squared, notice, it's not on my list here. It is not on my list. So I, again, have to get creative with this. So to do a problem like this one, I'm thinking Pythagorean. Anytime I see a square, I'm thinking Pythagorean. So here's what I know for the Pythagorean, that sine squared of x plus cosine squared of x equals 1. I want to get cotangent. Remember, cotangent is cosine over sine. So I'm going to divide everything by sine squared. And this is going to become 1 plus, that's just cotangent squared of x equals 1 over sine is cosecant, so this is just cosecant squared of x. That's allowing me to replace. Now, how long does this take? Just a few seconds. Get that answer right. So you want to know this one. So we know that 1 plus cotangent squared is cosecant squared. So I can rewrite this as cosecant squared of x dx. And this, I know, it is on my list. And that's just going to give us negative cotangent of x plus c1. The function whose derivative of cosecant squared is cotangent of x. And that's what this is looking for. We're looking for the function whose derivative is cosecant squared of x. And it is negative cotangent. All right, so obviously we have 1 plus cotangent squared of x is cosecant squared of x. If I divide these both by cosine of x, we would get tangent squared of x plus 1 equals secant squared of x. And that's our other one that we have to know as well. All right, let's try number 9. Again, over here, oh, look, I see a Pythagorean. This is our original one. Sine squared plus cosine squared is 1. If I subtract cosine squared, this whole bottom is just sine squared. So here I could rewrite this as cosine of x over sine squared of x. I still don't know what this is, but I can write this as cosine of x over sine of x times, because there's 2 of them, I can make that 2 different sine of x's, like so. And now watch what happened. Oh yeah, what is cosine over sine? But that is just cosecant of x, cotangent of x. And 1 over sine of x is cosecant of x. Oops. And this I do know. I know what that is. So by using a little bit of Trigs, I can able to split this up. And cotangent, cosecant, that is our list over here. Cosecant, cotangent is negative cosecant of x plus c1. So this is negative cosecant of x plus c1. Now remember, this is the original function. That's what this is saying. This function's derivative is cotangent, cosecant, or this is another way we could write it, of course. And remember, because of that plus c, this is not unique. We're going to talk more about that starting tomorrow, okay? All right. I hope you guys enjoyed the video as much as I enjoyed working with you on these. Take a look at them, and I will see you all later.